Yes, how was your day, Ben?
It's been great. Gotta go to the bathroom or something?
Well, yes, and I saw somebody walk down the hall, so I need to go catch him.
Oh.
And go to that.
Did you guys take the test? Doing the long division today? Oh, never mind. How you doing, Dave?
Great, how about you, Christian?
You good?
I mean, I think they're absolutely superpowered. I remember like just a while ago, I can't remember how to PlayStation.com.
Yeah, well, you can only do it when it's
Citizens who were outside of the country.
something about how powerful you are. Something to gonna explain.
Oh, we're getting out of 145.
I remember how to do it.
Wait, what?
I remember how to do long division. I don't remember how to do the
Since that like it promotes heavy use of entry.
you do the big L and you had it was like Ben, you're here. I haven't seen you in like a week. I've been spectating your Clash Royale games. You against Mr. Doge. It was so much fun.
Yes.
Oh,
I hate synthetic division. I'm gonna kill synthetic.
I've gained like 2,000.
If it was a person, well, even if it wasn't a person,
I
I
think
still would kill
I've lost one game. No, I've lost.
You're gonna hit me.
I've lost one game. And I've won.
Bro. Oh, is that the hacky stack?
No.
Oh, this is actually
Well, because I'm so over.
Yeah, I do not want to do
That's
long
so
division.
much
I like
fun.
those.
It's like the worst thing in math.
Big
Long
meeting.
division.
So true. So true. Yo, he's got the. Is that mayonnaise?
Dude, shut your mouth! I've gone through this for 3 years of my life.
Okay.
You're still eating?
Oh,
Okay.
I really did it because Diego did it.
I've never seen someone eat fries with mayonnaise.
Wait,
Fries
what?
Oh!
Fries with mayonnaise?
Fries with mayonnaise? That's not, I mean, I personally don't like mayo, but like, I mean, it's the same thing as eating.
Everybody was
Yeah.
piling on me for it. I'm like, it's not.
Hey, look, at least it's not like waffles and ketchup.
I'm sorry, Lou.
Exactly.
Oh my god.
You and your
I do not. I find mayonnaise like too much mayonnaise outside of a hamburger to be gross.
I
Listen,
mean,
I went to
I
Costa Rica.
personally don't like mayonnaise, but fries and
Time
mayonnaise
is fair.
doesn't sound that bad.
I went to Costa Rica, right? You have the red and yellow.
I'm ready to learn that.
Red is ketchup.
No.
Yellow is mayonnaise. All right, I promise.
That's just in my seat, I already know.
common.
Yellow is mustard.
Not in Costa Rica, man.
Mustard is the best condiment.
Well, Costa Rica's wrong.
No,
Mustard is
Costa
so
Rica
good.
knows how to eat their freaking fries.
A good cold broth.
No, you need some
Good
ketchup
cold
and some
broth.
horseradish. That's what you need.
A cold
He's
broth
eating
with
fries
mustard
with mayonnaise.
Amazing.
Okay, there are his fries.
Yeah.
How's that hurt you?
It doesn't hurt me. I just made an observation.
Do you know Clementine?
It's a nice squeaky mustard.
10 ketchup packets. You eat this mountain of ketchup. Like, unbelievable. Like, there's no way you're gonna use all that in one.
All right, guys, let's move on.
My friend eats like hamburgers with like 6.
Y'all can visit with each other when you're done with the assignment.
You should dog whistle.
They're not ready class they're tardy.
I should, yes.
Oh god. This thing was closed.
Okay, so we've got one more big unit that'll have a big test, and then probably a couple small quizzes, and then that'll be about all the time that we have this year before your summer break. So in our last big unit, we do sections 2.5, 2.6, and 2.7. And 2.5 focuses on the fundamental theorem of algebra, and so we will talk about that in next class. You already know what the fundamental theorem of algebra is. You probably just don't know that it is the fundamental theorem of algebra. And then in 2627, we review how to graph rational functions. So those are the functions that can have vertical asymptotes, horizontal asymptotes, holes, x-intercepts, y-intercepts. We find all that stuff algebraically and figure out what those graphs look like. And you should have done quite a bit of that in Algebra 2, so that should be reviewed. But before we get into either one of those two, we need to remember how to do polynomial division, because polynomial division will help us with both of those big topics. So today we're going to focus on long division and synthetic division. So let's look at question 1. And you can see all on the front page, the front of the front page and the back of the front page has those questions are asked you to do them both ways. So we're going to look at long division for a couple questions, and then we'll come back and talk about synthetic division. But we're going to work the same questions. That way, after we've reviewed each one, you can kind of do the one that you're more comfortable with, and then go back and do the one you're less comfortable with, and you should have an idea of what you're aiming for. So, all right, so long division is an algorithm, and you have to know how to set it up. So the divisor is the thing that goes out front, and then that goes underneath. All right, and then what makes long division an algorithm is there's a couple steps that you just repeat as often as you can. So the first part of the quotient, which is going to be the first part of our answer, needs to be the thing times m that gives us m squared. So that's why the first part of our answer is m. m times m is m squared. Now, you really multiply by the whole thing, though. So m times m is m squared, but also m times negative 8 would be negative 8m. All right, the next part I'm going to highlight on all the examples we do up on the board here today, because this is where the most common careless mistakes happen. What you're really supposed to do is take these terms and subtract all of those terms. But if you write it this way, what tends to happen is students will subtract this first one and then forget to distribute it. So what I'm going to emphasize, and the way I'm going to word it every single time, is after you do this multiplication, change the signs and add instead. Changing the signs is just like distributing that negative. So these two are supposed to add to 0. That's why I picked m. These two add up to 1m, and negative 11 plus nothing is negative 11. So there are the long division steps. We just have to start them over. Next part of my answer is supposed to be the thing times m that gives me m. So that would be 1. 1 times m is m. 1 times negative 8 is negative 8. Before you forget, quickly change the signs and add them instead. And now I can't apply the algorithm anymore because there's nothing times m that gives you negative 3 unless you make a fraction with m in the denominator, but that kind of defeats the purpose. So our answer is going to come from the quotient. Now, probably the first time you ever did long division was probably pretty early with numbers, and you probably had a teacher that did something like r negative 3. Remember doing the r thing? Okay, so that just means remainder negative 3. That mathematically doesn't mean anything. Do not do that. The reason why your teachers had you do that at some point is because when you learned this, you did not know or have a good understanding of fractions, so that was just kind of the way to get by. With the remainder, you need to add the remainder over the divisor. Add the remainder over the divisor. And since this is plus and negative, you could change this to just minus if you prefer. I'm not going to rewrite it because it's the same. Okay, I'm going to do one more as an example for you in number 2 long division, and then I'm going to have you try one to see how it goes with number 3 in long division. Okay, so the divisor needs to go out front. This would be the setup. And then the first step of long division, the first part of our answer, the first part of the quotient, needs to be the thing times n that gives us n squared. So that would be n, because n times n is n squared. Also n times minus 6 would be negative 6n. And then I'm highlighting this step to remind you to change those signs and add. That's the same thing as subtracting the whole thing, but just less mistakes. And then start over. So the next part of my answer would be 5, because 5 times n gives me 5n. You also have to do 5 times negative 6 to get negative 30. Before you forget, change the signs and add. And then your answer comes from the quotient plus the remainder over the divisor. Okay, so finish copying that one down as an example, and then try number 3 in the next couple minutes here to see if you've got that down or if there's immediately something that you need to add to your notes here. Okay, let's make sure that you did this correctly and then give you guys a chance to speak up if something looks different on yours. So here's the start, the setup. So first part of your answer should be what? Okay, because n times n gives you n squared. N times 5 would be 5n. And then I'd say the first common mistake is going to be right here. If you have 15n, then you need to focus more on changing these sides and adding. It should be 5n. 18 plus nothing gives you 18. So if you remember to change the signs and add, that meant the next part of your answer was what? Okay, because 5 times n gives us 5n. 5 times 5 is 25. And I can tell you from doing this many years, a lot of times students remember this one, and then if the question lingers on and you're near the answer, you get a little too, I don't know, a little too quick to move on. The remainder here is not 43 because you need to change the signs and add. The remainder is negative 7. So quotient plus remainder over divisor. That's what we are aiming for. Okay, so we're going to shift gears and go back to question 1 with synthetic division, but is there any steps in this that you guys want clarification on first? Okay, so back to question 1 then. So we're doing the exact same thing. We're dividing m minus 8 into m squared minus 7m minus 11. But synthetic division is a different algorithm and it has a different setup. So in synthetic division, you put a number up here in the top left box. The number that you put up there is the number that makes the divisor equal to 0. Let's see the question. Then you're going to have a string of numbers here that have to be the coefficients in order. So I've got 1m squared. Next I have -7m's. And finally I have a constant of -11. So all of that is just a setup. A little bit more setup than long division has. But Dennis algorithm only has 2 steps. And if you're not paying attention here, it's going to be over before you know it. You always add down first. So 1 plus nothing is 1. Then you multiply these two and put it here. That's the 2 steps. And then you do it again. So add down. Multiply these two and put it here. And add down. And now I can't do it anymore, so that has been finished. Okay, so our answer is not this set of numbers, but our answer is going to come from this set of numbers. 1, 1, -3 should not be your final answer. We started off with a 2nd degree m squared. So if I divided out an m here, this now represents how many m's I have. This represents my constant, and this represents my remainder. Everything has to be in order. So I have 1m plus a constant of 1, and remainders still have to be put over the divisor. Now the divisor is not 8. 8 is just the number we put in up here in the top left for the setup. The divisor is still m minus 8. But notice, whether we did long division or synthetic division, is the same question, should get the same answer. Different process. Okay, let's do that again on 2, and then I'll have you try it on 3. So the number that should go in the top left would be the number that makes n minus 6 equal to 0. So that would be 6. You have to list off the coefficients in order. I've got 1n squared minus 1n minus 29. And then we add down and multiply, add down and multiply, add down and multiply as many times as you can. So add down, 1 plus nothing would be 1. Multiply these two and put it here. Add down, multiply these two and put it here. Add down, and then we get a string of numbers here, which is close to the answer, but it's not the answer. Don't say that that's your answer. We still have to interpret this. We started off with an n squared, and then we divided out an n. So now this first number tells me how many n's I have, because it's lowering the degree by 1. After that comes the constants, and after that comes the remainder. Remainder always needs to be put over the divisor. Same thing we got with long division. Okay, so you try question 3, and if it matches your long division answer to the left, you can go ahead and start the next question, and you don't have to wait up for us now. But there's a couple small things I want to point out to you. Just a couple tips that you may want for page 1 and 2, but we will do those tips and then go straight to the back page so we can talk about how these things are different and not just how they're similar. Then I will give you time to finish up the rest of it. So should be pretty manageable without any homework. 1 over here, AJ.
It just wasn't the bottom portion.
Okay. So if you ran out of time there, or you did not get the same answer that we got on the left, you need to follow along with me to see what went off. So first off, the number in the top left should be -5 because it's where the divisor equals 0. So not +5, but -5. The coefficients come next, but they have to be in order. So you can't say 10, 1, 18, because this would mean you have 10 n squareds, 1 n, and a constant of 18. You have 1 n squared, 10 n's, and 18. So there's the setup. And then add down. 1 plus nothing is 1. Multiply these two and put it here. Add down. Multiply these two and put it in the next spot. Add down. And you just do that as many times as you need to. And then we turn these three numbers into our answer. If I started off with the quadratic and I divided out a variable, this has now been lowered a degree, lowered by 1. So now this represents how many n's I have. After that would be the constant. And then the last number is the remainder. Remainder needs to be put over the divisor. Same thing as this one. So, which one of those methods do you like better? Alright, that's what most people say. So in the back page we're going to talk about why do we need long division then if synthetic division seems to be a little bit smoother for us. But I've got 2 tips for you for questions I'm going to ask you to work on here in just a few minutes. So notice question 4. I want to make sure that you set up this synthetic division correctly. What number do you think we should put in the top left? Okay. And then how many a squareds do I have? Okay. And then I have a constant of -28. If you do it like this, synthetic division is great, but everything has to have its place. So if I can't see this and I'm looking at this, it looks like you're saying you have a constant of -28, and then the next biggest thing would be your a's. So this is really like saying 1a minus 28. It's supposed to be 1a squared. So what we really have is 1a squared, no a's, and a minus 28. So as much as you guys like synthetic division, if you don't put that placeholder in there, synthetic division does not work. Did y'all address placeholders like that in Algebra 2?
Yes.
Okay, good. Okay, so that was one tip I wanted to give you. I still think that you can do it, so I can help you, of course, but I don't want to do too many of these with you because really you need some practice. I'd also say on 6 and 7 in the next page, don't divide by 3 plus k, just divide by k plus 3. Instead of -1 plus k, just do k minus 1. Just rearrange those. Like, there's nothing wrong mathematically with dividing by those, but for your sanity, to make the questions look a little more, a little bit more the same from question to question, just go ahead and switch those 2 terms, would be the advice I give you there. Okay, and then moving on to the last page. The rest of this you can practice on your own. So why bother with long division when synthetic division seems easier? Well, long division is the only type of polynomial division that always works. So it's kind of like the quadratic formula. If you're going to only learn one way to solve quadratics, it has to be quadratic formula because that's the only method that works 100% of the time. With dividing polynomials, if you're only going to learn one method, it needs to be long division because it's the one that only works. So on these last 1, 2, 3, 4 questions, notice I'm not telling you to do it both ways. It's not saying do long division on the left and synthetic on the right. Partly because some of these can only work in long division. And I want you to do whichever one you think is easiest. So then the next logical step is to know when you could do synthetic division. When can you do that instead of long division? So you need to know that synthetic division only works if you're dividing by x plus a number or x minus a number. So that's a 1x to the first plus a number, or 1x to the first minus a number. Quadratic doesn't work if, synthetic doesn't work if this is quadratic, and it doesn't really work if this number is not a 1. And that's technically not 100% true. There is a couple more steps you can learn and then do it that way. But to be honest, I don't even remember those. I'd have to look them up. So it's not worth the extra steps you have to memorize. Okay, so this problem here, can I use synthetic division to do this?
No,
Okay, I agree. And why not?
because it's 2x plus 3, not x plus 3.
Right, that 2 in the front complicates things. So just do long division there, don't do synthetic division. Synthetic division will not work the way you think it will work. Okay, how come I can say yes? How do I know long division is going to work?
It always works.
Okay. Why does this one always works? So those last 4 questions on this page, I guess you could just do long division on all 4 of them because it always works. But I think there's 1 or 2 of them you could do synthetic if you prefer that. Okay, I've got one more thing I want to make sure that you guys are aware of, even though it doesn't matter too much today. It's just something that doesn't come up enough in Algebra 2, and when we get on to graphing and stuff, this is a very useful tool, and it requires 0 more work. It's something called synthetic substitution. Y'all ever heard that term before? Okay, synthetic substitution means when you synthetically divide by something, like 8, the remainder, if you pair these 2 up, it tells you a point on that graph. So synthetically dividing by 8 gives me a remainder of -3. That guarantees that the point 8, -3 would be on the graph of m squared minus 7m minus 11. So if I was trying to graph that function and I wanted more information about it and I needed to do synthetic division anyway, pairing these 2 up as a point is what's referred to as synthetic substitution. So in the second question, with 0 more work, I can tell you that that equation goes through 6, 1. The one after that goes to the point 5, -7. Or I'm sorry, -5, -7. So that's just too useful when it doesn't give you anything. The one that you're probably most comfortable with, most familiar, is when the remainder is... What number do you like to see as a remainder? Probably 0, because that means it goes into it evenly, which tells you that it's a 0 or an x-intercept. And if you think about it, if this was 6, 0, then that on a graph would be an x-intercept. It would be a 0. And it would tell you that n minus 6 or x minus 6 is a factor because it divides into it evenly. But that's just good if you know that, but you don't really need to use it today. But if you try to tell yourself that with each question, then you're more likely to use it as a tool in the next week or 2.
We will use that.
Yes. Okay, so now I'm leaving you alone, giving you about 10 or 15 minutes to get a couple of these under your belt. My suggestion to you, starting with question 4, is just do whichever one of these you're more comfortable with. If you think synthetic's a lot easier, do synthetic first, get an answer, then go back and do long division. And if you can see that your long division answer is different or is going to be different than your synthetic division answer, then that tells you that you've got a mistake, and it probably will help you see what your mistake is. So that's how I would recommend moving forward. Yes, sir.
For long division
Yes.
on 13, to get it to add, would you do a negative? Or, like,
For long division?
yeah.
Is 13 part of the practice?
Yes.
Like, so like, to get it to like add to cancel out, would you have to do a negative 10?
Yes, because negative 10 times 2x is what gives you negative 20x. And you want that to be the same. So, yes.
Okay.
Okay, and again, just try to get a couple done. If you're not getting the same answer on both sides, then you might find one or two that you want to ask about. But I will give you a chance to speak up and ask a few questions on the board. In about 10-15 minutes. But you should aim to finish this in class. I will collect this at the start of class on Wednesday. And it is opened in Google Classroom already. So if you finish it in class, which you more than likely will, you might just go ahead and take your pictures and turn it in, and then you don't have to worry about it.
Yeah. There's x minus 10 minus x. Yeah. We're supposed
has been 10 minutes. So again, yeah, especially on the front and back of the first page, you guys should know if you're on the right track or not. If you get the same answer on both sides, it's probably fine. But is there any questions that seem harder than the others? Anything you want to ask about? Okay. Switch the screen over then. So again, please go ahead and turn this into Google Classroom as you finish. If you don't finish in class, you guys still have another 40 minutes. So, but if you don't finish in class, then that's what you need to do for homework. I will ask for it at the start of class on Wednesday. All right, baseball guys, you've got just a couple minutes, so. Both sides?
Yes, sir. Feels good today. I don't know what it is.
He's speedy like that.
I swear I don't take drugs.
Yeah.
I don't take performance enhancers.
Caffeine is a drug.
Do it.
Caffeine is a drug.
I don't
He's not on
drink
that
caffeine.
stuff.
I'm actually LDS. I don't drink coffee.
No Coke.
Rarely. I try to.
It's got caffeine
He's
in
on
it too.
drugs. What?
Huh?
You on drugs?
No, not that.